Hi everyone. So I'll give a talk on how reasoning can help with AI governance. I don't intend to talk too much about AI governance. Francesca Rosi's talk in this workshop covers that very well, and there are other talks also that talk about what AI governance is. So I'll not talk about AI governance as I just mentioned. So I'll explain what's the role of explainability in AI governance. We keep coming back to this question: can LLMs reason? If so, what kind of reasoning? How can we improve LLMs on reasoning? I'll talk about two frameworks from IBM, InstructLab, and DGT, and I'll finally conclude my talk. So, explainability can be extremely helpful for AI governance. As we know, these large language models and in general deep learning models are black box systems. So we do want to understand what is going on when a decision is being made. So if there is better explainability, it can help in, for example, first understanding and then mitigating any biases, increase trust, accountability in these models, reliability, and few others. Like you can probably extend this list and add other items too. At a higher level, there are two types of explainability in LLMs. Here I'm only talking about model agnostic methods. So global explainability and local explainability. In global methods, we are talking about overall behavior of the model. For example, what each neuron is learning. On the right hand side, you can see a figure where it shows what neurons in each layer are learning in case of a convolutional neural network. Here we can understand with global explainability limitations of the model, how prone the model is to attacks, and other stuff like that. In local explainability, we are interested in a particular outcome, how that outcome was decided. So explain a single decision point or single data point. There are methods that do counterfactual explanation. For example, what needs to be changed in the input so that the decision becomes different. Okay, for example, in case of classification, what needs to be changed in the input so that it is classified as a different class now. So I'll focus on local explainability, and within that also instant based explanation today. Okay, so we are at reasoning with large language models. Can large language model reason? First we need to understand what is reasoning, and when we talk about reasoning in context of large language models, what type of reasoning are we talking about? So there are two, again, very abstract level categories in reasoning. One is formal reasoning, the other is informal reasoning, also known as natural language reasoning. So a formal reasoning is where we use symbols and we have rules defined, either manually crafted or learned, and there are formal reasoners that perform the reasoning steps, and we have some guarantees also. Given the full information about the environment, we can give some guarantees. The issue is that it can be very complex to define real world in terms of rules. So formal reasoning systems struggle because of the rule induction part of it mainly. The other is natural language reasoning. This is human-like understanding and human-like reasoning. It's very subjective, but it's much more general. You don't need to define the rules in the way we define for formal reasoning systems. So LLMs perform informal reasoning. They do natural language reasoning. It can be subjective at times, so you can disagree. Someone might like it, someone might not like it. In formal reasoning, it's either correct or wrong. Okay, so no one can disagree. But in natural language reasoning, it can be subjective. Okay, so this is the reasoning that LLMs are doing, and we are talking about here. When we talk about informal reasoning with LLMs or natural language reasoning, chain of thought is the most important kind of reasoning that these LLMs do. Chain of thought generates steps that leads to the final answer. Okay, so first of all, it breaks down our problem into smaller problems that are easily understandable by humans. It how we know it works is that it also increase the final accuracy. So if you get some accuracy without chain of thought, just by adding the reasoning steps in the prompt, the accuracy usually improves. And of course, it makes it much easier to understand why the model thinks what it thinks. Let me give you some example. So here, for example, I show how chain of thought prompting is different from standard prompting. In standard prompting, you ask a question and you expect an answer from the system. In chain of thought, you give a question and you give the steps that were involved, and then you give the answer. And you can give few examples and then you can ask a new question. So the system will also act in the same way. It will break down the problem into smaller steps and then give you the answer. It can be few shot, it can be one shot, it can also be 0 shot. But overall, if you look at the big circles, lined with big circles, you can see that a chain of thought almost always give better results than standard prompting methods. So there is a lot of benefit of these, instead of just going to the final answer, defining these steps in the reasoning steps in the middle. Okay, so as I said, so it can be also zero shot chain of thought. Okay, so in 0 shot chain of thought, all we do is we ask the system to think step by step. Okay, so we just add, let's think step by step, and we get the accuracy that is much better than if we don't say let's think step by step. So on the right hand side, you can see a big jump on 0 shot when we add this prompt, like asking the model to think in a stepwise manner. So here is an example. When asked what is the largest state bordering Mississippi River, the model can give you the answer, but when this was run in early days of GPT 3.5 or ChatGPT, it gave a wrong answer. Okay, where it says that Louisiana is the largest state bordering Mississippi River, which is wrong. If you just add things step by step, what it does is that first it tries to find out which states border Mississippi River, then it gets size of the states, and then it picks the largest state and it finds the correct answer, Minnesota. And as you can see, if it makes some mistake, let's suppose in the area of some state or the states bordering Mississippi River, it's much easier to find here. But on the right hand side, where we don't ask it to reason or give us the intermediate steps, it's so difficult to understand why the model is doing what it's doing. Is reasoning an emergent ability of LLM? Maybe. It only occurs in large models, but large models, the definition of large models are changing. It was initially thought that the models over 50 billion, 70 billion can show reasoning capability, but recently much smaller models are also showing very good performance on reasoning benchmarks. And the reason is that it does not only depend on the size of the model, it also depends on how the training, how many flops the training was done, what are the parameters of the hyperparameters of the model training. Of course, number of model parameters also contribute to this. And very important part is the data size it was trained on, and even more than that is the data quality it was trained on. Okay. So yes, you can think of reasoning as an emergent property, but it will not, smaller model will not get better at reasoning unless you provide them with very high quality data, and you train them with good parameters, hyperparameters also. So how can we improve reasoning in large language models? First, so here I want to talk about reasoning with smaller models, like less than 20 billion models, which are much more practical due to the value that they provide. I don't want to talk about the state of the art, the largest models, proprietary models out there. So in the recent months, we have seen like smaller models have improved significantly on reasoning, and one of the main reason here is very high quality of training data, and this training data come from different sources. It can be highly filtered version of existing crawl data, or it can be synthetically generated data. If you look at Phi 3, you can see, for example, the family of Phi models, Phi mini, which is 3.8 billion parameters, Phi 3 small, which is 7 billion parameters. They perform very well on some reasoning benchmarks. You can see like numbers for MMLU, big bench hard, empty bench, which are a combination of tasks. They are, for example, MMLU consists of 50 different subtasks. Big bench also consists of 23 or 27 smaller subtasks, and depending on how you count. So smaller models are getting better at reasoning. How can we generate the high quality data? Let me briefly talk about synthetic data generation, and then I'll show two frameworks or tools that you can use from IBM. Synthetic data existed before ChatGPT or self-instruct also, but self-instruct made it much more famous. It demonstrated that how we can use LLM by prompting it to generate more data. There are a few issues. It's very difficult to control the quality of the data, so there has been work done on in this area. Diversity, if you do simple, like if you give few examples and you generate a lot of data with it, it looks different, but it is following the distribution of the parent or teacher model. So how to increase diversity, domain adaptation, where we can adapt it to out of distribution tasks, and grounding, for example, where we can ground it to knowledge bases or documents. So these are enhancements that are done in many papers after self-instruct's original paper appeared. So InstructLab is an open source tool by IBM and Red Hat. The motivation of this tool is to help make people contributions to large language models. Okay, and the purpose is to make it very easy for everyone to contribute there. Let me explain a bit more. So as we know, there are many large language models that exist in the open source space, but it's not possible to, it's okay to use it. People can use it, but you cannot contribute. You cannot make a contribution to that model. Okay. So what InstructLab does is it allows people to contribute to the large language model training also, and of course you can use the models afterwards after the training is done. And why this is important is, for example, an LLM is performing very well on general reasoning tasks, but you have a specific reasoning task, let's suppose chemistry reasoning, okay, and it's not performing very well. So what you can do is you can make a contribution to the training pipeline through InstructLab, and the next iteration of the model that will come out of this training will do better, will probably do better on the task where you provided some example data. And also, it's very difficult to do data governance if it's not centralized, and this is also where InstructLab help. where the community can provide additional skills or knowledge. Skills and knowledge are a bit different because knowledge is grounded on the knowledge graphs or data or document. It's model agnostic, and the community can add new skills and knowledge to the training data. How it is done is there is a taxonomy that is defined. The user can either extend the taxonomy or add new examples in the taxonomy, existing taxonomy. Okay, and within all these different nodes, new data is generated, and then the data is filtered, and then the training is performed on that data. So let me talk about intuitively a difference between simple STG and taxonomy based synthetic data generation. So you can see that the input in case of self-instruct is very smooth. On the other hand, if we do taxonomy based input distribution, it's spread across many different domains because we intentionally provide examples in many different domains. If you look at output distributions, again, so if we do very smooth self-instruct kind of a prompting, we see that the teacher mostly generates the data as per its own distribution. On the other hand, if we do taxonomy driven seed examples, then we see the output distribution that is much more broader, and it tries to improve the model in many different domains. Here are some initial results from Instruct Lab. You can find the latest results in the GitHub repository. So Labradorite 13 billion and Merlinite 7 billion, they're both based on open source models, which are Llama 13 billion chat and Mistral 7 billion instruct respectively. And you can see that it improves the performance on many benchmarks, including Empty Bench, MMLU, and others. So Instruct Lab allows people who have no data science or large language model expertise to make contributions by providing few examples in the domain of their interest. This is very easy. This makes it very easy for anyone to contribute towards the open source model training, not only being a user of the model. But there are advanced users who want to generate complex data generation pipelines, and they want to use those pipelines, their own pipelines, to generate new data and make contribution to the open source model. This can happen through another project of IBM called DGT, which stands for Data Generation Transformation Pipelines. Okay, and here what you can do is you can make contribution not only by providing few examples, but by providing the whole pipeline of the data generation. You can think of, for example, state-of-the-art pipelines that exist like chain of code or self-discover. Someone can come and implement these pipeline or some other pipeline in this open source project, and that will be used for generating data in the next iteration. So just briefly explaining, this is not a work from IBM, and probably you already know about this. Self-discover is where they provide 39 or something types of reasoning, and they ask the model to first pick the appropriate types of reasoning and then perform those reasoning. And chain of code is where the problem is solved not only by language, but it involves code and running the code in an interpreter. So improving large language models on natural language reasoning can significantly help AI governance. As I showed, they can increase bias detection, They can increase interpretability in general, um, increase the trust in these models, and so on and so forth. High quality data is the key, and at IBM we are working on some projects to make this high quality data generation more accessible to masses and let the community make contribution to the next iteration of the open source model. So just repeating myself again, so instead of just being a user, now the community can contribute to the training of open source model, and they can expect that the open source model will keep becoming better in their domain also that they care about. Thank you. Here are a few ways to connect with me. You can scan the QR code. It will take you to my LinkedIn page. Thank you so much.